why we use a unit circle in trigonometry. Let's understand that concept. Before that, let me give you a short introduction about what is a unit circle. A unit circle is a circle with a radius of 1 unit. We also know that when it comes to trigonometry, we're gonna watch a triangle is placed inside a unit circle. Like this. I will be talking about the opposite side, adjacent side, and hypotenuse in terms of sine theta, cos theta, and tan theta. Before going there, we know the Pythagorean triangle. This guy gonna give us the relation between how this hypotenuse is related to the opposite side and adjacent side. But what's the significance of it? It's quite simple. Whenever you want to know the values of any point on the circumference, you're gonna draw the x and y axis. When it's a radius, when it contains a radius of 1 unit, the x can go from +1 to -1, and similarly the y +1 to -1. In this range of values, no matter which point you consider on the circumference of this circle, might be within the range of -1 to +1 on both x and y coordinates. Suppose if you want to know the value of this point, you're going to draw a radius, which is r equals to 1, and you're going to draw a perpendicular to find the value of x, and a horizontal to the x to find the value of y. But I'm going to consider this horizontal here because that's going to give you the same value. Now, this is a right angle triangle. We make use of this right angle triangle with the help of the Pythagorean relation to figure out or to understand how this radius is related to its opposite side and adjacent side. But who is the one who is deciding their values is this angle. Therefore, theta acts as input value here. That means for each and every point on the circumference, there will be certain angle that is associated with it. It's going to contain theta 1, this is theta 2, this is theta 3. So each angle has its own opposite length and adjacent length. In this particular case, we have a relation which is drawn, that is sine function, cos function, and tan function. Here, sine function is directly proportional to opposite side because the hypotenuse is 1. Therefore, the radius is 1. That's why. At this particular case, if you want to study about the sine value, you can directly talk about the opposite length of the triangle. With the help of Pythagorean, with the help of the sine function, you're talking about the opposite side in terms of sine function depending on the theta that is obtained with respect to the x-axis on the radius. Similarly, the cos function. The cos function is talking about the adjacent side. Hence, the radius is 1 because the hypotenuse is 1. In this particular case, if you take any point on the circumference, you can talk in terms of cos function and sine function. Because theta will be similar whether your radius is 1 or 1000. Doesn't matter because the angle is similar on every case. If your theta is 30 degree for radius of 1, it is same for 1000 as well. So, to make the relationship of opposite side to adjacent side with respect to each angle that we are figuring out, we're going to make use of a unit circle. At this particular case, you're going to have hypotenuse as 1. Therefore, the sine function obtain a direct relation with opposite side and cos with adjacent side. In this case, if you want to know the value of any point on the circumference, just measure the angle. Just measure the angle and apply the value of angle to the theta value. Let's say this is around 90 plus around 30. Let me take it as 90 plus 30. This will be your x coordinate and sine of 90 plus 30 will be your y coordinate. Isn't it easier though? In this particular case, if you want to know about the entire angle, this is how the angle chart looks like.